challenge. Now you get to hear all the best pitches from all the different challenges. So the first team I'd love to invite is Team Constantine Quantum Technologies. Over to you. Are you ready with your presentation? And
yes, I will be presenting in replacement of Mohammed.
Perfect. Please get started. The next teams I want you to get ready as well is QNYC, Curious Quantum Submission, Salada Bowl, WinQC. So please get ready and be ready to present. All right, let's get started.
Hi, we are Constantine Quantum Technologies, and I want to present you an idea for number generations as a service. Now, first of all, the product will be random numbers that are uniform and non-reproducible using quantum. This will be for scientists and cryptographic science and security. For the security part, companies can directly communicate with us for us to send them, or rather, they would send us requests, and then we send them their random numbers in a secure and specific channel, the channel that is specific to them. For scientists, it's even easier. Scientists don't have to do anything on their side. We can collaborate with HPCs, and scientists can work on their HPCs in the usual way. For example, here they use NumPy to generate random numbers, and then the HPC, sorry if you can see this, and the HPC will automatically substitute the code and use our package that presented earlier. Now, how to work with other cloud providers? Well, traditional quantum computing companies, they focus on universal quantum computing, which means that they have a lot of constraints on their hardware and, of course, on the cost. For our service, we can use any system and any quantum system as long as we initiate it, superpose, and merge it. This makes it very scalable and cheap. And in our package, we already are using at least three backends, so 3 quantum systems. And that's it.
Perfect. Thank you. Great presentation. All right, and next we go over to QNYC. Are you ready?
So our company name is QNYC, and this is the problem we aim to solve. There's a famous saying by Einstein that states, if you can't explain it to a 6-year-old, you don't understand it yourself. For a very long time, quantum mechanics was a field that many scientists did not understand, which made it inaccessible to those who did not find themselves in academia. However, times have changed, and we're now at the edge of a revolution, the quantum age. Quantum is no longer a topic that can remain at the highly academic level. If we plan to be prepared for the quantum age, we need an expansive and diverse workforce who are ready to launch this in the future. This starts with developing digestible, representative, and accessible education to Black and Brown students. If you have taken a look at our website, the homepage uses bright colors and encouraging statements such as quantum is for everyone to grab the reader's attention. When you scroll down, the field of quantum computing is introduced with a funny skit that encourages students to keep learning more. As they travel to our Learn page, they receive a breakdown on differences between the classical and quantum computer, which then leads to a full analysis of the hardware behind the superconducting quantum computer. The lecture notes are digestible and run through implementations of animated graphics and reaffirming quizzes. It is also paired with 2 more videos to further comprehension. In the videos, you will notice the main speaker sets a relaxing tone in order to remove the difficulty that is associated with quantum. Lastly, in our About page, to establish a connection between our readers, you can find our mission, description of the team, and another funny skit describing the applications of the computer. But we don't aim to stop there. As college students, we are able to outsource help and recruit other students to help the initiative. Our goal is to develop a nonprofit quantum computing program to help inner city students build a career in this space. We will train college students to teach the middle school/high school students the material such that they can begin to develop their own. We plan to prepare educational challenges at the end of each program session that the students must complete and post on our website. This will further develop a quantum computing community between Black and Brown students, and as a result, increase the diversity in the field. And that is the end of our presentation.
Thank you very much. All right, next up, we have the Curious team. Curious with a Q.
Yes, just a sec. I'm trying to find the right. Okay, I will share the screen. So. Hi, Juliana from Curious team. Balancing the energy contribution of a supermarket with solar energy production, in-house batteries and car battery charging and discharging station is of paramount importance for CO2 emission reduction and to create nearly autonomous energy grids. Team Curious proposes two different approaches to the optimization problem, an instantaneous optimization and a time integral optimization. The instantaneous optimization is designed to balance the energy contribution, deciding which unit should be charged, discharged, or do nothing at a given time frame. The time integral optimization has access to the past and future of every day and use discretized charging rates for fine-tuning of the energy grids. For our goal, we also explored conventional implementations such as CPLEX and simulated annealing and different quantum algorithms, viewing quantum annealers with CQM and BQM, QAA on simulators, and Qiskit runtime. On the left, for instantaneous optimization, you can see in-house charge battery levels compensating weather condition and mole consumption on 2 different days for 10 in-house batteries and a lump mole battery. On the right, for time integral optimization, a visual balance for all energy contribution is displayed. Our preliminary results do not embed all the effects yet, and still work needs to be done. But what we got already shows an impact on reducing CO2 emissions with respect to the not optimized case. We are building solutions that can be scalable up to realistic cases on quantum annealers and can anticipate a rapidly changing quantum hardware scenario, leveraging practical advantage of quantum annealers and quantum advantage that can be claimed on gate models. Thank you for your attention by Team Curious.
Thank you. Right.
Thank you, Prachi. Just if I may, we would also like to hear the business side of that solution. So you had the different pitch, right? I think that was missed in the, if you could just spontaneously, add that on, that would be perfect.
Please, Alex.
Hey, hi guys. Please give me just 1 second.
No problem.
Pardon. All right, can you guys see my screen?
Yes, we can.
Okay, thank you. So on the business side, not only do we have our quantum solution, but our impact analysis also shows that there's vast potential and the timing is now perfect more than ever. There's tremendous market scale demand, government as well as media support, and with basically next to no established competitors. Financial feasibility also provides that profitable. Curious is profitable even at most conservative calculations, even for supermarkets that need to implement EV charging stations. And our marketing solution, for example, the Curious app, also enables quantum communities, clients, as well as companies and their customers, and increase more business opportunities like CRM. In terms of scaling, there is a huge scaling potential. For example, as you can see, 3 supermarket brands alone totals up to more than 8,000 stores. Impact with our strategy is projected at around 1,200 stores already within the next 3 years. This is also yet to consider high growth EV markets like Southeast Asia and potentials beyond supermarkets to any businesses with parking spaces that our solution can be applied to. Thank you.
Awesome. Thank you, Alex. And thanks for reminding us, Barbara. All right. So next, I'd like to invite Salada Bowl to come and present.
Hello. Just give me a minute to share my presentation with you.
Yes. Hi, Saba.
Hello again. So can you see the slides?
Yes.
Okay, okay. So hello everyone, we are Salada Bowl, a team of specialists with physics and computer science backgrounds, and we have worked on IQM's challenge during Hackathon. Variational quantum eigensolver is a quantum algorithm to find the ground state energies, and this has been successfully applied to quantum chemistry so far. Meanwhile, the current VQE method has too many quantum gates, so this causes tremendous error when we run it on a NISQ device. One way to overcome this issue is to reduce the number of gates in the quantum circuit, and this can be done by changing the groups of digital gates by their equivalent analog blocks. We have applied our reduced quantum circuit to solve the ground state energy for lithium hydride molecule, and as shown in the right figure here, the accuracy increases more rapidly even with a smaller number of quantum gates. More interestingly, on NISQ device simulations, our solution shows vastly improved performance over the conventional VQE, as you can see here on the right plot. And this shows the noise robustness and the scalability of our model. But we haven't stopped here, and we also come up with another application beyond quantum chemistry for our DA-VQE model. It is a new quantum machine learning algorithm which has a great potential for industrial applications. In fact, we have shown its high performance in a certain data set, as you can see here on the plots. This is the summary of our work. Thank you very much, and we would like to thank especially to the IQM team.
Wonderful, thank you. Great presentation. Next, WinQC, can you please present?
Hello.
Hello.
Can you see our screen?
Yes, give us just a second. We can see your screen. You need to make it full screen so we see it bigger. Perfect.
Is it? Okay, thank you. Okay, so we are WinQC, and this is our presentation for the IQM challenge. Our problem was to simulate a variational quantum eigensolver, or a VQE, on the DAQC framework, digital analog quantum computing. So let's say if someone wanted to calculate the ground state for hydrogen, they would traditionally use the quantum phase estimation. But with NISQ devices, VQE actually performs better. DAQC is an alternative framework where we use alternating pairs of digital and analog blocks so that we can simulate things with fewer gates. For our implementation, we tested 3 different DAQC ansatz and 1 DQC ansatz. And we tested our code by simulating hydrogen over varying number of analog digital block pairs, which we call iterations. To make things fair, we replaced the analog block with a pair of control Z gates so that for each test, all the different implementations had the same number of gates. So we could see how well they performed. On to our results. So when we compare all of the different methods, when it comes to noise and error mitigated cases, we find that all of the DQC versions actually outperform the DAQC ansatz. Interestingly, the fewer parameters we have, the simpler our ansatz is, the better it performs. And as you can see, for over 5 iterations, our code is actually very static. But all these random perturbations actually come from the optimizer itself. As you can see over here, this simulation, it is very noisy. If I were to put, instead of 300 iterations, 299, this wouldn't work.
10 seconds. Yeah. I recommend going to your conclusion.
And in the future, we hope to improve the optimizer, increase the number of qubits, and work with different connections. Thank you.
Thank you. All right. So I want to next invite Constantine Quantum Technologies. I know you had a solution for the ORCA problem as well. So if you can present that solution.
Oh, I did present that solution.
Oh, that was the first one. Sorry. Then can you do your quantum, the one for QWorld?
Okay, so I will share my screen just a second.
Awesome. Thank you, Nasser.
You can see my screen, right?
Yes, we can.
Okay. So here I want to present our simulator, which we did. It can be a great training tool for students or for anyone who will work in the field of quantum computing. So you can see it's very easy. Just import and then declare your circuit, how many anyons per qubits. We can perform some braiding operations, and here we can see an example of a braid. So these are the line words of the anyons in 1 qubit. We can highlight one anion here in red. The simulator also gives us the braiding history in terms of sigma operators. We can also visualize the unitaries of our circuit in a very nice way. There's also the computational and non-computational basis in TQC, so we can get all of the basis states. So if we want to use qubits, we just use 2. If we want to use qubits, we can use everything. And here is an example of an actual simulation. So we simulate this braid 1,000 times, and we give it a random, an arbitrary state to begin with, and it will compute with the accuracy the output of the circuit. As we can see here, it's a so-called between state 0 and state 2. It can also handle multi-qubit topological circuits. Here's an example. So we have 2 qubits here with 4 anyons each, and they interact. And we can measure also the circuit. Here's how the measurement is done in TQC. Again, we can draw the unitary, and we can have results. We can have results just like in the last. In the case for one. Again, here we are giving it an arbitrary state, and we are in our measurements 1,000 times, so for 1,000 shots. And here's a histogram showing all of the results of the braid that we saw here. So it's actually a physically accurate simulator, and as I said, it can be used either to simulate circuits for actual devices or to just train people on TQC. Thank you.
Awesome. Thank you. Great presentations, both of them. All
Thank
right,
you.
next we go to Nelido.
Is that
me try?
video? Yeah. Let me share my screen.
Perfect.
Yeah.
Awesome. Thanks,
Yeah.
Neil.
Can you see my screen?
Yes, go ahead.
Yeah. So this is Neil JDO, and I worked on the Quantum NLP with Lambek challenge. So for that challenge, we tried to answer the question, can we use Quantum NLP for sentence topic similarity? And so the task is, given 2 sentences, can we tell if they are from the same, if they're talking about the same topic? And based on my results, yes, we can do it with 90% accuracy. With the given with 90% accuracy with the default IQP ansatz available in the Lambek library, and with QNLP methods, we have the added advantage that the model is not a block box, since the grammar is grammatic information is inherent in the model, and this could be a possible new tool for NLP practitioners which they can use to improve upon classical approaches. And the next question I wanted to answer is, can we do better with the default ansatz? And again, the answer is yes. So with the custom ansatz that I implemented, we get 97% accuracy, and more importantly, it trained 7 times faster than the default ansatz with minimal number of qubits and reasonable circuit depth and parameter count. And this is an example comparison with one of the state-of-the-art classical NLP model that exists. And so so the dream with QNLP is bring back the language in NLP and have efficient training and extend capabilities of classical NLP. And then for the possible implementation is a quantum NLP-based assistant, wherein human level question answering can be done, and domain agnostic applications can be performed.
Awesome.
And so for future work, I've listed down here several ideas on how we could proceed or achieve that goal. Yeah, thank you very much.
Perfect. Thank you, Neil. Great presentation. All right. Next, we have Q-linguistics.
Pardon?
Yeah,
You need to present. Oh, understood. So let me present.
Can you make your screen full screen? We don't see it. And yeah, your time started. So please start.
To the QNLP models for performing binary sentiment classification. So for this task, we created our own data set using 300 sentences labeled as either depressive or non-depressive. We try to reach the same performance as of neural nets, only faster, and trying to take as much of the quantum advantage as possible. For our solution, we experimented over 3 categories and different parsers based on sequence of word importance, different pre-processing, sentence level versus diagram level, and our own ansatz, which was the SIM13. We tried to maximize the current performance. These are the parsers that we use: the spider reader, the COPS reader, Trader, and Bobcat reader. The last 3 of which are sequence dependent. We also created our own array of pre-processings, which allowed the Lambic model to go from 50% accuracy to 100% accuracy, to remove emojis, check dictation, remove connectors, punctuation, determiner, auxiliary, as well as our own suffix tokenizer. And this was our own ansatz, SIM13, which allowed us to get a faster result. And this is the summary of it. So the left-hand side, we see our model, 100% accuracy on training, 0.05 on loss, 93 on validation, 0.15, and lastly, 84 on the test accuracy, smoother convergence as compared to the right-hand side, which is the Bobcat. And lastly, we had better accuracy without loss of generality, so we still perform well in test accuracy. Sorry, I'll wrap it up with class. And we also had a smoother convergence compared to Bobcat. And our future work is that we hope to be able to add these sentence level pre-processings to Lambic's documentation, and also to write our own spider reader and create more tokens, and also try to see if QPUs are better choice for the backend. Thank you so much.
Perfect. Thank you, and very stylish presentation. All right, next I want to invite Code Diggers to come and present. So,
hello, my friend's sharing the slides. All right, without further ado, step right up. We want you to face off in a battle of intellect, wits, and cunning against a quantum computer. For the Humans versus Quantum Computer Challenge, we interpreted the challenge as a call to create the first quantum game AI, one which can leverage the terrifying computational power of quantum algorithms to command game strategy. We will make quantum mechanics our opponent. The final product, Milk Simulator. Milk Simulator is a turn-based strategy breeding game where quantum strawberry milk cows will try to outbreed the player's chocolate milk cows and force them to extinction as they compete for resources. The player will take turns with the quantum game AI, moving their cows in between 2 pastures in an attempt to defend chocolate milk from the megalomaniacal quantum strawberry milk cows. The quantum AI strategy is to keep the game in a Nash equilibrium. So every selfish move the player makes will punish the player. This Nash equilibrium, which is a concept from game theory, is found as the solution to the NP-hard max-cut optimization problem. The player will go toe-to-toe with this strategy to have any hope of saving chocolate milk. This game has several exciting implementations as well. It would be very easy to run within a web app that sends the quantum AI tasks to a quantum computer. This way, it would be simple for the everyday person to just open the game on their phone, face off against a quantum game AI, and share their strategic genius with friends or on social media, thus getting more excitement for quantum algorithms. It also shows a quantum applications process flow, which has startup potential. We have demonstrated how to make a problem from game theory, a mathematics which is ubiquitous in fields like finance and politics, which have hard and expensive problems. And our solution shows how to encode these tasks into quantum optimization problems that can be hurled at the Herculean might of quantum computers. Finally, I would like to leave with a call to action to demonstrate quantum advantage gladiator style. We propose that if a quantum AI can battle a classical AI and consistently win, it is evidence that the same quantum algorithm has an advantage and has earned the right to usher in the quantum advantage era. And so with that, I'd like to ask, are you smarter than a quantum computer? Thank you.
All right, I'm really pumped to solve that problem. Next up, we have GermCam computing. Yeah, kudos in the meantime. All right, is GermCam here?
Hello, can you get me?
Yes, Mark, we can hear you. Go ahead and present.
Okay, I'll start sharing my screen.
Awesome. And everyone else, please go on mute, unless that's Mark with the background noise, but everybody else, do mute yourself. Awesome. Go ahead.
Okay, can you see my screen?
Yes, yes, go ahead. Just make it full screen and get started.
Okay, thanks. Okay, hello everyone. I am Fumak. Can you get me?
Yeah, please go ahead.
Okay, hello everyone. I am Mark Harrington from Team Jekan Computing, and I'll be presenting to you today the Quantum Ludo. I know most of us here, we are familiar with playing the classical Ludo game. We might have played it physically or actually digitally. This game has been a source of entertainment, a tool for skill development. It has also been a tool for friendship and collaboration. However, since this game was implemented, it has faced certain drawbacks. The first drawback that this game has faced is the actual fact that it has implemented in a biased method. This game has implemented in a manner that the game actually chooses which player wins the game. Secondly, this game is limited in the fact that it actually needs at least 2 players to play the game. Then by limiting the person who actually wants to play the game alone. That is why Jekan Computing is actually presenting to you today the Quantum Ludo. The Quantum Ludo is actually a web game implemented in a manner that you can play the game real time with these certain features. Here are the following features. The first feature is actually that this game is built on the foundation of quantum computation. That means with this feature, it actually uses the principle of superposition to make it a fair game while digitalized in a real life manner. Secondly, this game actually gives the player the ability to play it on an IBM quantum computer. Okay. Actually, according to the implementation and scaling of this product, we can actually compete from the market validation of our competitors. For example, Ludo, which is a popular game on Play Store, you can actually see that they have actually over 50 million downloads, and this actually shows a proof of the available market for Quantum Ludo. Secondly, our target
time's
users,
up, Mark. So if you want to get to your conclusion, time's up.
Okay, so why don't just join Jekan Computing to bring Quantum Ludo to life? Thanks.
Right. Thank you. Please be muted. Perfect. Thank you. All right. Next, we have Sharp G Debians to talk about their web problems. Great. We can. Your presentation's gone.
Okay. Are you able to see the presentation?
Yes, we can see it and we can hear you.
Okay. So hi, everyone. Imagine that you have a linear system that you want to solve and that you have at your disposition a quantum machine. This quantum machine can solve the system in 2 seconds if its size equals 10. But as the size grows exponentially to reach some very big values, such as 10 to the 12, you realize that the data encoding would take thousands of years, while your solver would take only 12 seconds. This is the case of what is known as the HHL algorithm. The origin of this problem is the data encoding algorithms that we have. For example, the amplitude encoding algorithm that we've studied has a complexity linear to time, which compromises the advantage of the HHL algorithm having the logarithmic complexity. One possible solution would be to teleport the initial state to the HHL algorithm, but this supposes that we have some quantum sensor that could easily prepare the states. So we are going to pursue another path that could be very useful for solving some problems related to synthesis of 2D materials. 2D materials could be used to fabricate new kind of qubits and enhance development of quantum computers. The simulation is done through what is called molecular dynamics. So our input is of two kinds: substrate, a solid with a very ordinated crystal shape. So the data follows a pattern, and we could hope that there exists a quantum algorithm that could prepare this data in something less than polynomial time, than linear time. The gas has some random positions that we could simulate using, for example, the result from other challenges such as the random number generation using Poisson sampling. Once we have our initial states, we are going through. We will try to solve the equation of motions that we have linearized beforehand using the quantum Kalman linearization. Then we could apply our boundary condition and read out the output. So thanks for your attention.
All right, thank you. Thumbs up to you too. All right, next we have Entangled Web to come and present their solutions.
Yes, that's me. Let me share my screen.
Thanks, Luis.
Okay, can you see this?
Yes, go ahead.
Okay, yeah. The name of this presentation is End-to-End Quantum Simulation of Orbits of Telescopes. Problem statement. The main objective of this challenge is to explore ideas that can be implemented to solve linear system of differential equations. Some of the questions we had to ask ourselves are: can quantum algorithms solve system of equations efficiently? What type of technologies are needed to collect data, and can it be encoded efficiently? To explore those questions, we had to simulate the orbit of a satellite. We had to build a quantum circuit that can prepare quantum states, and we also spent some more time exploring the possibility of solving the protein folding problem by solving a nonlinear differential equation. These are some of the things we had to do to implement our ideas. To predict the position of a satellite, we had to solve a linear system of differential equations using the HHL algorithm. We had to solve the system multiple times to simulate the orbit of the satellite. And we also had to use teleportation to transfer quantum states from the satellite to an institute or lab. To prepare quantum states, we had to permute amplitudes of states systematically to minimize the number of operations, to increase the efficiency of our program. To explore the protein folding problem, we had to think of ways to measure the position of atoms accurately to define the initial state of proteins. We also spent some more time trying to figure out how to use signals as gates. Our program encodes classical data as a quantum state in n log n time, which means that if we use a program, we wouldn't be able to outperform a classical computer. So that means that we have to come up with ways to increase the efficiency of our program. We think we might be able to do that if we use experimental measurements directly to do quantum operations. Some of the ideas we explored to solve we spent some more time exploring ideas that might lead to a way of solving the nonlinear equation that can describe the protein folding. We chose this problem because we think solving the problem would unlock a chain of breakthroughs in medicine, science, and engineering. Thank you.
Awesome, perfectly on time. Thank you, very interesting solution. So next we have UCLA Bruinium. Love to invite you to come and present. All right.
Hello, can you hear me?
We can hear you. We don't see your presentation. Perfect. Now we can see too.
All right, perfect. Are you able to see my screen move?
No, not yet. It says has started sharing, but we see a black screen.
Let me try that one more time. Sorry.
My timer is not working either.
Perfect.
Okay, now it's working. Perfect.
All right, perfect. Okay. Hello, we are UCLA Bruinium, a team of aspiring quantum scientists from UCLA Chemistry and Physics with a mix of PhD students and 3 undergraduate students. We set out to demonstrate one of the direct applications of the near-term implementation of quantum computing and quantum chemistry simulation. A cost-effective way to simulate the potential energy of molecules would be monumental to theoretical research, with direct applications to real-life problems in environmental and energy storage chemistry. The first step to this eventual technological goal is to optimize the problem for small molecules, come up with innovative ways to design QED circuits, and expand to larger molecular systems. And so for our project, we demonstrate our various approaches to stimulating the potential energy surface of lithium hydride. As a summary, we successfully minimized the circuit depth of simulating lithium hydride, as well as troubleshoot different backends. We captured the full potential energy surface of the molecule, as demonstrated here with our own VQE Hamiltonian and ansatz. In addition, we tried a new approach that would differentiate our product from other companies. Our approach is unique in that we simplified the problem from simulating the full molecule to doing it in 2 pieces, representing the core and valence configuration separately to calculate the ground state energy of the full lithium hydride molecule. This approach will scale in accuracy and cost efficiency with larger atoms and bigger molecules, which would be a great future direction. So with this team of experts with diverse backgrounds and collaborative spirit, we came up with an innovative approach to address this quantum chemistry problem. And so moving forward, we think a chemically informed, creative approach like our solution will lead to more innovative ways to create cost-effective QED simulations of larger molecules. And thank you.
Awesome. Thank you. Very good presentation. Next up, I want to invite Pontoon Zone to come and present.
Yes. Just share my screen. Is my screen visible?
Yes, we can see your screen.
Okay, amazing. Hi everyone, this is Team Quantum Web. Our problem? Assume we have proved quantum advantage over classical devices for a problem. Is it possible to improve this quantum advantage by exploring different quantum methods? Also, which are the possible metrics that we can use for comparing a quantum algorithm results? We try to explore these questions by focusing on the portfolio optimization problem using QAOA and CVAR approach. Using different combinations of the listed specs, we try to find any trends with respect to cost of gates, time, accuracy of the optimal value. These are the observations from my experiment. When the use case performs well with less qubits, large number of qubits will adversely affect the performance with additional noise. For a particular case of optimizers, it is showing different results, different costs with respect to alphas, while we try to simulate it on the simulators and the backends. Cost decreased as alpha value decreased and lower values led to faster convergence. Smaller initial points parameters gave faster convergence. Adding more repetitions can help us increase the accuracy of the optimal value, but this was not observed in our case. Running algorithms over the cloud is much more time consuming than running them locally. Finally, we also checked the real-world performance of portfolios selected by our combinations in our experiment over a period from 18th August to August 23 over some Indian market stocks. And the winner in our experiment was Quantum Simulator using gradient descent optimizer and alpha of 0.25. But we don't claim that the trend will continue in future for larger problem sets. A warning, portfolio optimization is a complex task involving several factors. Our dataset was too small to draw solid conclusions, and the experiment was based on the ideal quantum computer. Time taken to classically compute the results was much faster than the quantum backends for our small use. Thanks Stuart and Aisha Bill for their advice, and we loved working on the challenge. Thank you.
Awesome. I'm glad you did. All right. So next up, I want to invite Q-Polis to come and present.
Okay. Do you see my screen?
Yes, we do, Rina. Go ahead.
I will just do it in full mode. Okay, hello from Cupolis. Our work here consists in analysis and optimization of the hydrogen molecule on different quantum computers and comparing different quantum backends. We apply error mitigation on a sample circuit and use VQE with different backends. First, this is a list of prices of different backends. We also apply optimization on the hydrogen circuit, where we optimize the circuit depth, the CNOT depth and count by reducing these values through these two tools that are provided to us by PTCAT. We distinguish IBMQ and IMQ. For good results, IBMQ is rather cheap and IMQ is quite accessible and gives us accurate results. This is a summary of the reduction results. We've also applied error mitigation on a sample identity circuit that we created ourselves on QASM with the zero noise extrapolation method. Ideally, the expectation value should be 1, but due to noise, it decreases and the mitigation value increases it again. We want to apply this method also on the hydrogen molecule. These are the VQE ground state energy results for noisy mitigated simulation and noiseless backend. We see that for the noiseless case, the approximated values are closer to the exact values, which means that the lesser the noise, the better it is. Future perspectives, we want to combine even more optimization techniques. What we started, we want to expand it. We want to use more error mitigation techniques, including novel ones like accreditation protocol. This is an ongoing research that I'm doing at NYU, and apply all these techniques in VQE. So the mitigated values will be closer to the exact values. In the end, this is our vision. VQE is the Tesla Roadster, and our mitigation and optimization techniques are the SpaceX thrusters, which will make the VQE run along the road of quantum chemistry. Thank you.
Wonderful. Thank you, Rina. Right, next up, we have business as usual.
Yep, one sec. Let me just share my screen real quick. Okay. Okay, can you guys see my screen?
Indeed, we can.
Okay, sounds good. One sec. Okay, so good afternoon, everyone. My name is Akshita Tiwari, and my partner's name is Tanik Swain, and we're from Business as Usual. We are at the Academy of Science located in Leesburg, Virginia, and we use quantum machine learning to determine the lifespan of a patient with adenocarcinoma. So we know lung cancer is a big problem, and let's just talk about current oncologists. They make lifespan predictions with an error of a year, which is far too much for us. So our overarching goal is to proactively predict this life expectancy, accounting for factors such as age and gender and smoking status, but while also preserving accuracy, because we value personalization over research. So the 4 pieces of the pie that you see on your screen right now are the components to make our quantum algorithm. We used PCA, unitary function, kernel matrices, and then finally we compared it to a classical algorithm, and this is what we found. Our quantum classifier had a 37% accuracy, while its classical equivalent was just 4%, which just shows the scope of which quantum can do. And so why is it critical to bring our product into the market specifically? Well, we have efficiency, our 37% versus the 4%. We also have the accuracy and projected demand. Nowadays, when we were discussing this, we realized that when we turn the corner, we see a teen our age vaping, and this could lead to health problems, unfortunately, in the future. And also the practical importance of our algorithm is the personalization and quality of life. In the healthcare industry, we care most about quality of life. If a patient only has 1 month left to live, we won't do extensive chemotherapy in them because their happiness matters the most to us, and we want to be proactive. Our next steps, we want to optimize and expand into other types of cancer and then increase the accuracy of the quantum machine learning algorithm as well. So thank you for listening. And now for the pun of the year, we hope you choose business as usual. Thank you so much.
Awesome. Thank you. This was quite the roller coaster. So now next we have, as per the agenda, I know we are supposed to go and deliberate and pick the winners, but I did want to invite my judges, if you have any questions for the teams, or if you want to just take a breath and just ask questions. You've all done an amazing job, great presentations. Any key questions from my judges, especially as you think of who should win the Startup Potential prize? All right, have I missed anyone's pitches, judges? Anyone else that should be invited to present? No. Okay, we've seen some really excellent pitches then and presentations. So kudos. Give us about 10 minutes. We go into a judging room and we come back. Give us about 5 minutes. Take a break, relax, and we'll have an award ceremony and a reception afterwards. And my judges, you can meet me in the judging room.
Sorry, where is this judging room again?
Yeah, I'm just making it.
Oh, okay. Thank you.
Yeah.
Prachi, all breakout rooms will close or open? Open, yeah.
I just want to open the judging room. So let me erase these ones and then open the other ones. But for the rest of you, stretch, take a break, get some coffee.
Excuse me, I have a question for Amirali.
Yeah, go for it.
It shows the website that you used to, create this awesome presentation.
You're too kind. Thank you so much. I sometimes go overboard, so really sorry if it was like too visual.
All right, my judges, if you come to the breakout room, sorry, weird interruption, but I think you should be able to join now. Go ahead.
Should we join the breakout room or not?
No, breakout rooms, I think, are only for judges.
Oh, understood. Thank you.
Yeah, so if you're not a judge, please stick around here in the main room. Only judges should be going to the breakout room.
So, Jyoti, we can't hear you.
Oh, yes, sorry.
So what is the meaning that we presented again? Were we nominated for the startup prize or was it for the quality of the presentation?
Yeah, so if you presented again, you were either in the running for the general category winner or you were nominated to compete for the startup potential winner. I unfortunately don't have that data on hand, and the way that the award ceremony is structured is that they'll all be announced at once. So that's the plan.
Okay, thanks.
Yeah, and I mean, if you're taking a break and you're away from your computer, that's great. If you have questions, I can try to answer regarding demo day and the award ceremony. That's also great. Otherwise, I don't know. We can also just chat, guys. How did you feel? Was there a presentation that you saw that really impressed you, other than your own, of course, hopefully?
I like the other team in my challenge. I don't remember their name, but they used some very fancy pictures about the hydrogen and the industry. It was really attractive the way they had done it. I don't remember their name. They're somewhere here.
Yeah, well, thanks, Rena. And whoever she's shouting out, great work to you guys too.
I think it's Ashley, if I'm not wrong, but it was a really good looking presentation.
Thank you. You did a great job too. I think everyone here did a great job.
Yeah, I have to say, I was very busy on the back end, just, moderating duties, but Akshita's presentation and Caleb's presentation, you guys you very much stood out to me just by audio. Very dynamic presenters. So yeah, great work. And everybody else also did phenomenal.
Yeah, May. My name is Raíssa, and I'm also from the Womanium team. And I'd just like to say that you got an amazing work of the Hackathon team. But more than that, I'm looking forward to see many more hackathons from now on, because it was super amazing to see all of you presenting today. It's such an amazing job that you did. So it's really nice. So thank you. It was really a good job. And yes, maybe as Yot said, if you have questions, something that you'd like to share with us.
After this program, how many of you are now considering a career in quantum possibly? Or how many of you are like, no, I'm not considering a career in quantum, and I know that now. Maybe we can try to change your mind.
I'm already there. So I'm already in the quantum career. I've started my PhD, but now I'm also considering a startup career in parallel to the quantum one. So it really gave me extra skills to do the hackathon, more than just technical, because I also had to deal with other members. And I also one time I spent the night in the library, in the NYU library, to work for the hackathon. So it was really a teaching experience.
Thank you so much for sharing that. And yes, as much as it sounds as the typical hackathon experience, pulling that all-nighter, it's definitely a grind every time. So yeah, that's great to hear. And that was actually, I should have made it more specific. That was the flavor of this hackathon, right? Which was not only, maybe making a career in quantum more possible for you, but specifically an entrepreneurial career in quantum. And so managing a team, being a team player, being able to communicate your ideas and pitch are all very critical elements in the industry.
Yeah, absolutely. Yes, I'm Parminder from AWS. I was a global lead for automotive. I'm just changing my role into quantum in a few weeks. Industry is new. We need the graduate students coming out of the master degree or PhD, but at the same time, there is a room for people with consulting background or who have been in the industry in the classical side. Because one thing you need to know is the limit of the quantum too. Because hype can slowly go down if you don't know what your limit is in coming years in the NISC era. But I'm happy that I'm in this field, and then I'm happy to see my colleagues and and the Womanium team who have arranged this. Thanks to you all for participating as well as arranging this.
Yes, thank you, Parminder. Sorry, did you say you were at Amazon?
Yeah, I work for the Aviant Web Services.
Okay.
And I'm taking a new role. I will be working with the ISV, the independent software vendors, like Classic, the QCI or Quantinuum, to take them into the AWS cloud and use that backend to build some of the software application like that.
I see. So you're going to be working more on the quantum software end?
Yeah, mostly with the companies like Classic or the ISVs, what we classify.
Yeah, very cool. Yeah, I think I'm most familiar with I'm forgetting the exact name, but the more like applications and research focused teams for quantum. But if you don't mind me asking, it would be great if you can kind of share with everyone here in this transition period, kind of, going from, it sounds like software that doesn't have to do with quantum into quantum software facing kind of applications and work. What is kind of what you're finding most challenging and how you're kind of navigating that process, just in case other people here are thinking of making a similar transition. Up to you to share.
Yes. So let me see how best I can answer that, because the people like me who have been in industry for 20 years or so, where we probably have graduated our bachelor's and we are in the middle of our career, it takes little time to unlearn that classical side of the things, right? You have to come up with a new thinking. You have to put yourself in the shoe of a quantum grads or who are still in school, and think from that perspective, like what is superposition, entanglement, and what is quantum mechanics, the science behind that a little bit. So you have to take those baby steps. There are tons of material, and there are expert advice from a lot of people. But if you really want to dive deep, I think taking a graduate course in this field would be my recommendation. The reason being, I started that journey last year. I'm doing my master's from the University of Polytechnic Madrid. It is a good program for people like us who work full time, because it is it's like on the web through the conferences and all. You don't have to be in the university. It takes a little time to understand, but you have one good thing with those people who have been in the consulting industry for the last 20. You know the problems, you know the industry side of the house. So it will be good to apply that knowledge and then know the limit of the quantum, because most of the stuff which we probably will be dealing in this next 3 to 4 years is the hybrid style of quantum computing. So your classic computing is not going anywhere in near future. So my recommendation is take that leap of faith, join some universities, participate in a lot of summer school. Womanium is the perfect example. You can go for QSKIT. Recently, they concluded the simulation one. So build your base, and it will take months or probably a year or two before you start understanding this subject. If you don't understand the subject in a setting like a graduate course, you will not probably be able to be in this path for long. And it is a marathon, right? It's not like 100-meter sprint. So that will be my probably a small advice on this.
Thank you so much for sharing that level of detail. So what I heard from that was that building quantum intuition is really important, whether you are choosing quantum as your first career and you're like me in college, or whether you're an industry veteran and you're looking to make a switch. And also, if I'm ever talking and I'm muted, it's because Emily, also from Womanium, we're actually roommates here at Berkeley, so she's nearby. So some of that internal discussion or whatever details need to be figured out is just that's what it is. But I was listening, and that was really, really solid of you to share. Thank you for that, Parminder. And guys, this is an open discussion, right? Like, floor is yours. We can discuss, whatever we'd like while we're waiting for some deliberation to happen, or you can go drink some water, stretch a little bit. It's been intense for you guys.
Just like to the forum, do anyone know that is there any certification for quantum machine learning or any specialization courses there?
I was just about to go Google. I know IBM has various certifications.
But IBM does not provide the certification for QML. They have course,
Right.
but not
Right.
certified.
Right. Yeah. So, I mean, I don't know off the top of my head, but the other thing that comes to mind is just as Xanadu kind of repository.
I think for quantum machine learning, you can check the website of Professor Florian Marquardt. He has some courses for quantum machine learning.
Professor, I'm sorry, I just missed. I just missed the pronunciation. Can you please put that in chat?
Yeah, if there's helpful links that have to do with QML certification, yeah, please drop them in the chat. I'm sure people would love to see that. Oh, goodness. Keep screwing up the slide deck here. Okay.
Iot, we have a question here. Do you know if the results will be shared in the Discord server yet? The results of the hackathon?
Oh, yeah, I mean they will be announced in like probably a few minutes now. That's the next item on the agenda for demo day here.
Yeah. If they will be also like announced in the Discord channel.
Yeah, I think we can ask Maho to do that time after we finish with the deck. It'll be announced shortly after. Yes, right?
Okay.
Yeah.
That's just a question that I received
Sure.
here.
Sure. So yeah, and I think it was Shilan that mentioned some particular course. If you want to, I don't know if you're able to, but if you can direct message me that link to the certification you were talking about, I think some people are interested, and I think I have permission to share that with everyone. So.
Yeah, May, while you are here as well, I can just remind you that tomorrow you have the career fair, right? So it would be really nice if you have already like registered for it, like shared your CV. And we sent a Zoom link for some of the participants already. So make sure that you are ready for tomorrow's career fair. It will be also an amazing event with more than 20 companies. And I think it's really, really important that you are present on time and prepared. So just a reminder for all of you about the career fair that will happen tomorrow. Same time as usual. So
yeah. And I know that we had a pitch presentation session on, what day is it today?
Oh, last Saturday?
On Tuesday, I think. Or maybe it was yesterday. I don't know, guys. School started, so the days are just flying by.
Yes.
Yeah. So, and you know, just for those, there were like 70 people who came to that. So for those of you who didn't make it, you know, you guys had practiced the skill of pitching, you know, your idea today. It's equally, if not more, as important to be able to pitch yourself. That is the biggest asset that you have. And so I just kind of want to cycle back to what Parminder said earlier about, you know, like the basic, for example, he's built, you know, in the classical world of all the skills that he has as a software developer, right, is really, really valuable. And the unique thing about the quantum field is that we're all coming from so many different backgrounds. The resumes and all that are just going to look so diverse and so different. So don't sell that short. If you're new to quantum, am I echoing or somebody else?
From Mark, do you have a question? We cannot hear you.
Yeah, I think I'll mute him for now. He can
yes.
Right. So sorry, just to finish the thought there. Really, you know, if you're new to quantum and you don't have like the quantum mechanics or physics kind of foundation or background, I will say for some roles, like in software, it may not be as necessary compared to if you were building a quantum application algorithm. So it's, you know, really diverse, and apart from technical roles, right, there's plenty of business roles as well in terms of strategy, in terms of marketing. And so quantum is an industry. You can come at it from many angles. Please, I'm just wishing all of you the most confidence, the most courage to put yourself out there for the career fair tomorrow. It's just a message I'm trying to share. But I see that Amir Ali has a question here, so please.
Can I ask a very question from you, Ms. Rani? So I've been trying to ask you a question for a while about your research. You mentioned you're working on quantum cognition. Yeah. Could you like add some detail on what exactly you're working on and how it's different from the other works? Really interested on that.
Sure, yeah. So I guess I can tell you guys a little bit about the field of quantum cognition overall, if that helps. We had a very interesting discussion in one of the hack, what were they called, Emily? Hack sessions? The happy hours, one of the hackathon happy hours. Yeah. And it was like, we ended up talking about quantum cognition for like half an hour. So it's great to hear people are interested in that. Essentially, it's an intersection, I would say, of psychology and quantum in a very interesting way. So there's quantum consciousness, quantum mind, and then there's quantum cognition. They all kind of sound maybe similar, but especially quantum mind and quantum cognition, but they're two very different things. Quantum mind and quantum consciousness is a little more metaphysicsy, and I think the general thread of understanding there is that, that in our thinking processes and in various other biological phenomenon, there is like elements of quantum mechanics. Quantum cognition is, I think, more mathematical, and in that sense more concrete. And that's the idea that you want to use various quantum models. So for example, quantum Bayesian networks, quantum Markov models, to one of the main kind of cases people are looking at is to essentially explain violations of classical probability. So in small decision-making scenarios, there have been observed patterns of irrational decision-making that have been termed and classified.
Conjunction fallacy.
Yes, yeah. I see Amirali already knows them. Disjunction and conjunction fallacies. And there have been many kind of heuristics proposed classically over the years to explain kind of each one of these categories. However, I think one of the primary advantages that the quantum models are, maybe useful for in quantum cognition is that they are able to kind of two things. One, they're not ad hoc in that they are somewhat predictive in nature, but I think there's a lot of, it's a very emerging kind of area. So, if you dive into the literature, you'll see some debate regarding that point. And then the second thing is that they can be applied to conjunction and disjunction fallacy instead of having to have different classical heuristics explain each one of those. And so, the core of the quantum comes from, at least that I think is one of the most strongest cases for the quantum, is, for example, using an interference term to create a range of probability for a given mini small decision scenario, instead of having a set calculation that you would get from like the total law of probability from classical frameworks. So yeah, that is, I think, as much as I'm technically allowed to say, which is just a general context. But yeah, that was kind of an area that I was exploring, and I personally really liked it because it intersects with some economic and game theory models, psychology, of course, and the larger kind of conversation about cognition and understanding, the human mind better as well, which I thought was very, very fascinating to kind of be sitting at that intersection and also having quantum in the picture. That was very, very long. Wow.
No, it's good to go.
I hope some of you were also interested in the field. Yeah. And so last thing I'll say to kind of bring more of you, engage more of you in the conversation, is that quantum cognition ties in with, it's decision making at the end of the day, right? Which has to do with the rest of quantum machine learning, QNLP, and decision trees and all that good stuff. And so it's a small part that can integrate and maybe make our quantum machine learning models better and more representative. I think the real value is that it's able to kind of capture relationships between variables that maybe current models don't. That is one kind of strength that I think I've seen in the literature proposed.
So with that in mind, you pointed out something really interesting. My question is that in your model, the one you're developing, how does it differ from like the works of Professor Sornet and Professor Yukolov on their models of like Bayesian and cognition models or models of Feynman paths? How would you describe that your model would stand out considering the variables that you have that the other literature don't? Like some people, like Professor Sornet, worked on bias terms. Some other people worked on the model itself, like Feynman paths versus the evolution models. So I was really interested. How would you first describe your model? Like, is it something that you would feel like is applied to an environment, or is something like standalone? Like you have an AI, like QAI model. How would you describe like the innovation in it?
So if I understand the question correctly, Amirali, what you're saying is like how like a new kind of quantum model is different than like the existing ones that have been proposed in literature? In
your literature, basically what you're working on.
Yeah, I think my work was more actually tuned to so what we're kind of looking at now is seeing, so I like there's I think okay, I don't want to get too in the weeds. We can definitely keep talking, of course, in more in depth, but I just don't want to bore everybody else, right? Because it sounds like you've read a lot of the literature. So you have the context that other people might not. But what I'll say overall was sorry, give me 1 second. Okay. Yeah, I think that well, something that I was interested in exploring was understanding which one of these proposed models had already existed in the literature, kind of the connection between taking that and looking at, you know, applications that can come out of it. And so, for example, capturing the relationship between whatever variables, right? That depends on which application you're looking at. And so I think that's a step that's pretty exciting. That is also being asked in literature that we were interested in exploring, and it's ongoing. But yeah, I'm definitely, you know, very interested to discuss further with you. You know, offline. You can find me on Discord, and whoever else, you guys are always free to bug me. Yeah. Otherwise, I think deliberation is wrapping up, and it might also be the case that I need to check in with the Womanium team. So if you guys don't mind, yeah, let me just sync with them really quick and see what's going on with the judges. But apart from that, I think what we did was really cool. I don't know. Put your hand up if you hadn't heard about quantum cognition before. I can't see all of you guys. Hold on. Haisa, how many people approximately? Oh, I can.
Okay, 1, 2, 3, 4, 5, 6, 7.
No,
8,
I
9, 10.
got it. I have a count.
You got it. Yes.
Yeah. Only 8 of you hadn't heard of quantum cognition before? Really? That's really impressive. Yeah, that's very cool. Okay. Well, then, you know, for those like 8 to 10 people, you learned about a new field, new kind of subfield within quantum. And it would be really cool for the rest of you all to continue to discuss, you know, if you're very passionate about such a subfield. And I will say, I think that as you explore quantum, you know, it's very diverse. Like doing quantum chemistry, I think, is very, very specialized and specific as compared to maybe, you know, optimization models tailored to quantum finance, right? And quantum cognition is like its own thing as well. And so I think when you really start to find an application or like a sub niche, it really helps you stick to the field. So that's why it's like an open call. If anybody's super passionate about such a sub niche, please do share.
Maybe Perminda, do you have a question? No? Okay.
No.
Oh, yes, go ahead.
No, I don't have any questions. Sorry.
Okay, so you lower your hand.
Haisa, I think I will sneak into the judging breakout room for a quick second and be back. You've got it.
Don't worry, we will be here.
Awesome.
Waiting for you.
Yeah. Well, we're waiting on the judges.
Yes.
Deliberation always takes longer than expected, you know.
It's just 5 minutes.
Oh, are they back? They might be back.
I don't know. Yes.
I think they are back.
Oh, they're back.
Wow.
Okay. There we go.
Perfect
We're just talking about how you guys are, you know, really no, they're not back. I don't think they're back.
Yes, really on time.
No, yes, we are back. Well, most of us.
Yes,
Okay, they're back. They're coming back in 18 seconds. They will all be back.
So everyone, we are coming back. It was actually really interesting to deliberate about all the challenges, all the teams, especially given that people attempted to solve many complex challenges. They adopted different approaches. So it was actually an interesting deliberation, even among the judges, to evaluate and select the winners. especially when all the performers are so good. So now the judges will come and share their deliberations outcome.
All right, get ready. Clutch your seats.
Yes, so this is the moment we have all
and
been
get ready
waiting
to celebrate. Get the champagne out.
Yeah, Raj, we have that drum roll, right?
Yes, the moment you've been all waiting for and waiting for a long time. Thank you very much. It was an amazing session, amazing pitches, very hard choice to choose the winners, but the judges have decided. Before getting to that, this was all made possible by our sponsors. The whole hackathon, the whole program was made possible by our sponsors. The main sponsors, platinum sponsor Deloitte, gold sponsors IQM and Terra Quantum, and silver and bronze sponsors Atlantic Quantum, Strangeworks, Zapata, Atom Computing, Quantinuum, and Blue Force. An enormous thank you to all of you who made this possible.
And also to the sponsors, not only from our side at Womanium, but also from our participants. Not only that they sponsored the prizes, but also they provided challenges and provided mentorship throughout the program. And I think at the end of the day, more than the monetary prizes, the knowledge, the wisdom, the skills that they imparted to our participants will go a long way into the quantum world of tomorrow. So thank you for the wisdoms.
And then without further ado, we enter the announcement of the hack winners. The first challenge that will be announced will be IQM. Judges of IQM.
So for the technical detail of their solution and also for going beyond by exploring QLM methods, the winner of the IQM challenge is Salada Bowl. Congratulations.
Congratulations, Salada Bowl. Amazing achievement, amazing pitch. Congratulations, and use this prize to move forward and continue your project. Next, Deloitte Green Supermarket.
Yes, so we were very impressed with how much you achieved during the short time you worked on the project, and you tackled both the quantum technical part and the business part. So that was super impressive. And we are very happy to announce that the winner is Curious.
Congratulations, Team Curious. Amazing achievement. Next one, ORCA Computing.
Hi, yeah, so we have decided that because of their thorough solution and going well beyond the challenge description by including other quantum platforms, we're going to announce the winner as Constantine Quantum Technologies. And we'd also like to give a shout out to Yusuf for all of his work as a runner-up in our challenge.
Congratulations, Constantine, taking part in 2 challenges and winning this ORCA challenge. Quantinuum QNLP.
Yeah, so there were some really good solutions and really good projects. But our winner is Neil J. Doe, for his really good implementation of different ansats and the excellent results he achieved. And I'd also like to give a shout out to the runner-up Q-linguists.
Wonderful achievement, Neil J. Doe and Q-linguist.
Yeah, it was a close call between both your teams. So Q-linguist, congratulations as well. You did really well.
And the second Quantinuum challenge, TKET. Katrin, who is the winner in this challenge?
Hello, everyone. So thank you again for everyone to participate. We had a really awesome time grading and looking over your challenges. It was a very tight race here. So our winner is UCLA Bruinium.
UCLA Bruinium. Congratulations.
And that is for your thoroughness in your work, but we also want to mention QPolis because they did a great job for error mitigation and interesting cost ideas and also very great presentation. So QPolis, thank you too.
Special mention, QPolis, runner-up. Congratulations. Strangeworks, Stuart, who is the winner of this amazing challenge?
Yes, so for their interesting take on the problem and their nice sort of novel solution, the winner is Quantum Val. So
Quantum
congratulations.
Val. Congratulations.
Congratulations. And You will get special backstage passes from Strangeworks to work on your problem even more. Next up, IBM Quantum, humans versus quantum computers.
Awesome. On behalf of myself, Vishal, IBM Quantum, and my dog Penny, we're thrilled to announce the winner here today. They say that quantum computing sometimes looks like the wild, wild west, and so we need some good cowboys and cowgirls to take care of it. So our winner is the Milk Simulator, which is team... I don't see the slide.
I'm gonna break it.
You are diggers. There it is. Great job.
Amazing achievement. Core diggers, congratulations.
And most
James
stylish
Webb.
presentation.
Yeah, so for the James Webb Space Telescope challenge, the winner did an incredible job by creating a full scale for arbitrary number of qubits, both input encoder and HHL solver and teleportation circuit, and had a very clear presentation of the results. So the winner was G Debians. And I also want to shout out Entangled Web for doing an amazing job too, and almost reaching it as well.
Congratulations, G Debians. Then QWorld, for a lasting impact for the next generation of computer scientists and physicists in quantum computing. Gibran.
For the Quantum Hardware Education Challenge, it's Constantine Quantum Technologies for developing a wonderful, approachable introduction to topological quantum computing. And we look forward to actually incorporating the content in our fall course and hopefully future workshops as well. So great job. Thank you, CQT.
Constantine Quantum Technologies, you have been amazing this whole program. Next and last for this category, the challenge category, the Womanium challenges, Cryogenic Entrepreneurship Challenge, Video AI, and the Open Challenge. Prachi, who is the winner?
Absolutely. So the Cryogenic Entrepreneurship team did really, really well, thought through the problems. The Video AI team, I know you will keep going. The Open Challenge, this is where different teams had a portfolio optimization problem. Another one had a very different open challenge that they submitted. And then, of course, we saw another young team from Leesburg, Virginia, who made their own challenge of using quantum computing towards solving and detecting cancer. So the award goes to business as usual with their very bad puns or very good puns, if you like to say that. But congratulations, you've figured out a real world problem, tried to apply quantum computing to it, and again made your own challenge. So congratulations.
Congratulations, all of you, for these amazing achievements. All of you, the winners and everyone else who participated and learned many things and helped each other learn many things. And again, a thank you to all our hackathon mentors doing such a great job teaching everyone, involving everyone, educating everyone, and our sponsors, the cash prizes from Deloitte, IQM, Terra Quantum, Atlantic Quantum, Atom Computing, Zapata, and also physical prizes from Quantinuum, Strangeworks, and Blue Force. There will be some special prizes coming your way.
But the prizes are not over, because remember, this is quantum computing and entrepreneurship program. We're going from start to startup. So next, before, perfect, thank you, Marlo. So I do want to say, like, you have done amazing work, and some of you are very close to bringing this to the market, or we really like how closely your team can work together. And again, the real world application is what we're really focused on. So we want to start you off on the right foot with a small amount of seed funding so that you and your team can get started on the next steps of developing the solution further and bringing it to market.
So far, we were giving you award for everything that you have learned, the skills that you were able to apply. And we also want to take you and help you to catapult into something bigger. And that is where the Womanium's entrepreneurship part comes. And this is the part where we will be awarding the best entrepreneurship and startup potential award. And we hope that it will take you, not only the winners, but also the others, to think along those lines in future projects, but also in the future life. All the projects that you do, unless you take it into the real world and create a real world impact, the great work, the great discoveries that you make will be lost to the world. And we do not want your creativity, your ingenuity, and your potential to be lost to the world. And one of the best ways of giving it to the world is through entrepreneurship. So always keep that in mind. It is not just about winning this, it is about winning even beyond. And for the winning teams, our team will be providing additional mentorship, introduction to investors, and also preparing them so that they can actually take their current idea, develop it further, raise additional funding, and create that impact in the world that I just mentioned about. So it is not just for the winners, it is for the whole world. So keep that in mind.
Absolutely. Again, this is called seed funding. And the whole idea here is you take a little bit of money, get started with, filing the patents that you need or any kind of technical resources you need. Use this money, and the only purpose of this money is to get to the next step. And we want to help you through that entire journey. What is the impact you can make on the world? That's what we want to help you answer. So best startup potential winners then are, we have 2 winners because we couldn't pick one. Perfect. Malu likes to keep the suspense. All right, yeah. QNYC, we got such passionate judges came and said, you guys need to win because you've already tried to bring this to the market. It's should be very easy. I think we all heard their pitches. It should also be easier for you to develop the solutions and bring it to the market earlier. So we're really, really excited for what you've already done so far, and then what potential you have, and get just more people into quantum. And of course, business as usual. So kudos, great job. What I did hear feedback is technically you do need some help and support, and others from our team can come and help you. But your vision is in the right place. I think how you're thinking about the problem, how you're looking to scale it, all that's right. And use the startup award to again win more awards in the future. And we're here to help you, support you.
Thank you so much.
Yeah. Is QNYC here as well?
Yes, we're here. Thank you so much.
Perfect. Yeah.
Where are you? We would love to highlight you also in the video. Where is?
I'm here.
Can you raise your hand in the?
Oh.
No, not physically, but in the Zoom. Okay, perfect.
Yeah,
so, Yelisa, your team at QNYC, you did some really good startup and initiative, and many of the judges were appreciative of that. And we know that it is just a start. And we want you to start and go up and up and up and do something bigger. And this will be just as initial catalyst towards that. And business as usual, you both have identified a really good problem, but you have a pretty long way to go to solve it. And since you are young and you are driven, we want you to go all the way and solve it, because if you end up solving it, it will potentially change some aspect of the world, especially in diagnostics and medical field.
Awesome. All right. And we do have runner-ups as well. So these teams did really, really well. But nonetheless, we had a really hard time picking the right team. So, Mal, if you go to the next slide. Perfect. So Curious and UCLA. You both did really well. Actually, Barbara, if you'd like to come and talk about Curious and their path ahead. Or UCLA and the judges for UCLA of where you see their impact moving forward. Or Raj, if you want to cover this too.
Yes, Katrin is there to comment on UCLA. Yes, I'm here. I can go ahead on UCLA. Wonderful. So what really was impressive was definitely like your startup presentation was very well put together, but then also the fact that you're trying to look away from what's currently done in quantum chemistry regarding trying to figure out how to evaluate these ground state energies in a better way and more efficiently by making new approaches, which maybe possibly to be implemented easier on a quantum computer. So that was a very nice contribution. And that's why I thought this is a very well-deserved runner-up award.
Wonderful. And what we observed from Curious, you have solved the Deloitte challenge, not only the technical challenge, the business side as well. You've figured out some of the numbers as well. And we think you have a real path towards moving forward with this and implementing the solution as well. We also looked at some of the tables you created and your projections for revenue, where the market is. So all that's a direction and the right step. And congratulations on winning this award. We hope you continue developing the solution further and bring it to market. All right.
In addition, we will have some special prizes. Those we will keep secret, but you will see an email in your inbox to as a surprise.
And remember that the program is not yet over. We started a few 1.5 months ago with the training, with the lab tours, with the hackathon, and now the awards for the hackathons for people who successfully completed it. But for us at Womanium, this is just the beginning. We are actually creating additional partnerships, new programs that will take not only the quantum computing program further, but also we are creating a two new programs. And the first one will be on quantum sensing and quantum metrology. For that, we are developing partnerships with some of the largest companies in the world that does this kind of stuff, that develops sensors for satellites, sensors for aeroplanes, medical devices, etc. So this is just the beginning in the quantum journey. Stay tuned. And with that, we welcome you to a happy hour where just be happy, I think.
To celebrate the amazing challenges, amazing pitches, and the amazing winners. Congratulations, everyone. And we look forward to keep on collaborating together. We will keep the Discord alive, post everyone's experiences, new events, invite each other, start startups. Let's see.
Exactly. All right, kudos. So questions, thoughts, people want to make comments? Judges, if you have more questions.
And to emphasize again, we have been bringing more than 88 countries together in this hackathon and in this whole program. People from all over the world united in quantum computing, all the same goal to advance in this field at all ages, all different backgrounds. And this has been so special. We have heard many languages and we all unite in the quantum language and English, of course. And this has been beautiful. And even some hackathon submissions emphasize this diversity. Then the diversity of challenges and interests. You've been going from QNLP to a web challenge and heard from each other to keep inspiring each other and entering new fields within the quantum field. So amazing. Thank you to everyone for keeping each other inspired and keeping us inspired. And please send your input, what you would like to see for new programs. We have many ideas, but we are much more curious for your ideas, and we can create a program that you would like to participate in or maybe even help build. So post it on Discord, send us emails.
And also, as Dr. Marlowe mentioned, we had participants from 88 countries. But beyond that, we had participants who were teenagers, who were 15 and 16 years of age in high school. And we also had participants who were throughout every stage of university, undergraduate, masters, PhD, postdocs, and also researchers. And we also had professors. We had many professors from many countries come and participate. So even in the academic realm, from high schoolers to professors. And we even had beyond that, we had entrepreneurs, people who had started their companies, CEOs, engineers, technical people, CTOs, co-founders from many companies, from many countries too, from the US, from many of the European countries. So we had startup founders, we had investors from the US, and we also had investors from other countries. And I think this is actually a good opportunity to announce that while the quantum program was happening, while you were attending sessions, the Womanium founder, Prashi, she has been inducted to join an investment bank in Europe. And she will be helping to expand the investment bank's operations into the United States. And this bank, you can actually.
They're calling her now.
They're calling her all the time. But so there were many journeys that happened simultaneously and in parallel to what was happening on screen in the program. And during the program, one of our sponsors, Atlantic Computing from MIT, they raised about $9 million while you were attending the sessions. And they're also one of the sponsors of the program. So a lot of things were happening outside the screen that has been taking the quantum world further. But as I said, a lot of our participants, a lot of our speakers, they all come from diverse backgrounds, diverse countries, diverse ethnicities, and we are open to all. We make science open to all. And we had, as I said, students from the ages of 15 to even Nobel Prize winners, CEOs, investors. And I think that this kind of encapsulates one of the most successful programs. And thank you for coming and adding your ideas, your presence, and also making this program diverse and strong. I think that just as much as the Womanium team, as well as our fellows work hard to make this happen, all our partners, all our sponsors, companies like Deloitte, Xanadu, Atom Computing, Atlantic, IBM, ORCA, others. So everybody made it successful. And also you have also been an integral part of this program. So thank you.
So for the first time, I think we have most number of our team members here. We have Jyoti, Emily, Jade, Alex, Haisa, Maho, Madalena. So if you have questions for our team and you'll see our names with the Womanium behind it, maybe you could do some questions as well. If you're curious about these team members, you see me and Malu every day, but it's actually the whole team does so much work behind the.
And also before getting into that, I want you to remember that in life, life is cyclical. There is nothing is an end. Actually, this is your beginning to something bigger and grander in the world, in the quantum industry. And for us at Womanium, this is not the end of our program. This is actually the beginning of our program. In fact, in the month of March, 3 of us, Prachi, Dr. Marlu from NIST, and I, we were just having an evening conversation, and we thought, yeah, we need to learn what exactly is happening in the quantum domain. Let us make a fun and exciting program. And then we got a fun and exciting team. All our fellows, they come from different parts of the world, but they came together. They come from different universities and time zones. And we created a program which you attended. And the fact that you're here, the fact that many of you won, the fact that many of you participated, got certificates, it shows that we created a good program. But for us, it was just an experiment. This was our experiment 1. And we were trying to learn lessons about how to use different methodologies, different evaluation patterns, and also different platforms. For example, whether to use Discord or whether to use Slack. These were some of the deliberations that we had. So we would love to know from you some of the your experiences and feedback, so that when we create the next iteration of the program, it is going to be even bigger, even better, and even more scalable, especially in the quantum sensing. Many of the big satellite companies will be coming in presenting. So companies that have been making satellites since the 1960s. So these are some of the most experienced companies. They can actually come and share the trajectory of satellite and sensor development, medical and pharmaceutical companies, as well as research labs. So computing is one side, but there is sensing, material science, and other applications. So we'll start with the sensing and sensors, and we will go to other applications like quantum chemistry, quantum materials, etc. So for us, it is a beginning. So all your inputs will allow us to also create a better and bigger program.
And for us, it was also important to expose you to a wide variety of things in the real world, which can tailor your career paths independent of quantum computing. Many people are in academia and used to having lectures, you know what the academic career path looks like, but now you have seen entrepreneurs speaking, even some very young ones. One is here, Herman. You started your own startup very young age. Same age as many participants here. This is the time you can do it. The other people from industry, amazing talks by Quantinuum, IBM, ORCA CEO was there to advise you on your career. Quantum consulting with Deloitte, another very interesting branch that you could tap into. So we invite everyone to think about what are possibilities on your path and what do you want to pursue?
Yeah, why don't we start there? So everyone needs to unmute themselves and introduce yourselves and take a minute. Now, you know, I'll put a timer on too. No, just take a minute and tell us what you want to get out of it, like how you want to keep engaged, what you want from us more moving forward. Don't say startup winner prize. We can give you that too. But yeah, who wants to go first? Juliana, she's always like, but tell us what is the next step for you and how, you know, anyone here, the Womanium team, anyone here, Mustafa, who's next to you on the screen, how can we all help you?
For instance, now that we have really seen that our work has encountered some interest, we need to be mentored. We need help because I mean, if we are going to do a thing as a company together, I need to spin off from my center, and we have to create first of all our product and all the things that go around. So mentoring would be really great.
Okay.
And also you have done really a marvelous program. I think that it's important for students, for young researchers, for old researchers like me to get involved and to feel that we are part of a global community.
That's true. I see. Kai agrees. Kai from Deloitte. All right. Who wants to go next? Yusuf. Yeah, thoughts from you. Where can we support you? And who's ready to mentor Juliana? That's also a question. Oh, Yusuf disappeared. I guess I scared him. Okay.
It would be really interesting to hear what the startup potential winners are going to do next if they're here.
Exactly.
Yeah, perfect. Let's talk of them.
Yes, Yelisa and business as usual.
Business as usual had to leave for class.
Oh yeah, they're in high school. They're in high school, so they have to go back to class.
Yeah. All right.
And Haisa, our great career team lead, just asked me to do one more announcement for tomorrow's career fair. 23 companies will join us, all quantum computing companies from a variety of quantum hardware, quantum software, etc. And everyone here should join. Show your amazing pitching skills, show your amazing quantum skills, make them interested in you, chat with them, and see what is the best path for you. I think most of you already have submitted your CV. If you haven't done it, you need to be there. You deserve to be there. So still do it today, and we will send you the link. This great group of people, you need to be there tomorrow. Same time, new link.
All right.
Yes.
But coming back to our startup nominees,
yes.
What is the path forward?
Yelisa.
Yeah, I'm just really excited to carry out this project with my team, continue to expand, and continue to teach other inner city kids about quantum computing, especially coming from public school myself. We didn't have a lot of opportunities. The amount of career options are very limited to what we think is possible. So being able to bring that into schools that I used to go to and schools that my fellow friends used to go to, it's going to be a really amazing opportunity just to see how we can actually brighten up these individuals' minds. Thank you again for the opportunity.
Excellent. We will stay in touch and we will provide you with additional guidance, mentorship, connections, and resources so that you can accomplish those goals.
I have a question for you, Yelisa, because do you have any thoughts on the business side of this? Is it mostly sort of a non-profit thing, or do you think there are some ways to also, get that cash flowing?
That's actually something my team were thinking about at first. So we were debating a couple of ideas, probably running website traffic, having advertisements on our website, attracting more students, and then probably, even though we're still a non-for-profit, we can still charge public schools a affordable fee in order to have our program attended and things like that. But we haven't furthered the business development side of things in terms of making it a for-profit. However, we will to be interested in learning more about it and ways that we could maybe expand.
Herman would be a great mentor. You should reach out to him. But guess who's Herman's mentor?
Yeah, exactly. This is quite random. I just realized that now I'm eating food on YouTube, and that's called mukbang. It's a thing that people watch. It's to watch other people eating. So yeah, welcome to mukbang with Herman. It's actually a thing. Maybe that should be the startup potential to, yeah.
Stick to drones, Herman. Stick to drones.
Yeah. I said streaming on YouTube, but I was looking myself in the eyes while eating. So I just, yeah.
All right. Do we have the curious team here? Or UCLA Bruinium?
Hello.
Oh, Rina's here. Hi, Ashley. Yeah, what are next steps for you?
Oh, I guess for me, I'm on my last year of my graduate program, and so I'm really excited for the career fair tomorrow. And to be honest, I think somebody was mentioning, taking grad courses are important, like trying to go into this field. And I think being in my last year, I'm really excited for all the intellectual discussions about creative solutions to using quantum computer and algorithms. And this hackathon challenge was definitely one of the more enjoyable versions of those discussions. So thank you very much.
And which university are you at right now?
UCLA.
We're from UCLA.
As the team name says. All right, Rina, over to you. What are your thoughts? You came here because your team. Yeah.
Yeah, it was really good. So no, I wanted to share with you guys my experience with respect to Quantinuum, which is the company that we worked for, we did the challenge for. So a few months ago, I attended a webinar from Kevin Kauchak, I think, and his presentation about Quantinuum was amazing, and I was impressed. I thought, well, this is the company that I really like. They are doing exactly the things that I'm interested in. And now what happens after a few days at NYU, New York University, the physics department, someone else comes. His name is Mark Johnson, I think, and he's from Quantinuum. And I thought it can't be. It's again the same company, and he was explaining these wonderful things. But the problem is that he was talking about a new framework, TKET, and I thought to myself, this is new, but I have to learn it. However, I didn't have the chance to learn it in the upcoming months because I had to do courses and other things. But now that I got engaged with the Womanium, I finally had the chance not only to learn what it is, but to use these tools to do a real project with an amazing mentor like Catherine, who has supported us all the time. And now I feel like more inspired to do my own things, to continue my research in the error mitigation and optimization tools. So this really has been a game-changing experience for me, and I thank you all for this.
Rina, I think that the team from Quantinuum, they will be extremely happy to hear that. And I know that they try to engage with many universities, especially since they are a big company. But it is always good for big companies to know the impact they are doing and also the next generation of students that they are inspiring. So if Catherine is here, I'm sure that her heart will be full with emotions listening to you. I hope so. So again, Rina, thank you for being a part of this journey. And also thank you for sharing your experiences. And please do stay in touch. As we create the next set of programs, you should try to engage with us and participate very early on. And you will get to meet, again, great companies like Quantinuum, but also their parent company, Honeywell. They do a lot of quantum sensing. So Quantinuum is their quantum computing focused division. There will be also many others similar to Honeywell. They'll be coming and sharing their expertise, their experience. And it'll be great to have you in that journey too. Who knows what you will end up learning.
She'll make her own Quantinuum. All right, Nasser, he made 2 challenges and they won both. So kudos to Nasser and his team, to Constantine. Yeah. And I was also looking up Constantine, the city. It's a very, very beautiful city in Algeria, apparently a UNESCO heritage site too. So
yes, one of the old cities in the world. I mean, 26, 27 centuries old. Yeah, it's a great place.
And it is close where Claude Cohen-Tanucci is from too, right?
Yes.
Yeah,
exactly. Yeah. Where I used to live, there was a field which belonged to his family. We still call it Terra Quantum. And I mean, as a coincidence, now I'm working on the same field as him, called Athens. Yeah, I also just wanted to say, for this great event, I've learned a lot throughout these past. I've met a lot of very great people, and yeah, thank you. That was really fun.
And how will the team continue, Nasser? Because you can do everything. You have the best education module, a best technical module.
Yes, well, we will continue working on our cold atoms project. And well, if QWorld wants to incorporate the TQC into their courses, we'll be glad to help. And yeah, looking forward, any sort of collaborations with the quantum community. And actually, this event was also great for that. We have many people.
This is an invitation to all. Thanks so much, Nasser.
Yeah, so Yusuf, are we ready?
Yes. First of all, I really had to thank you for this amazing program that you made. This, honestly, I have to say that this is the one that I have attended many, and I have to admit that this was the most fun, first of all, and most fruitful one I have attended. I think that's definitely important thing if you just keep up doing these things, because you just bring people at the point that they meet different ideas and backgrounds, they come together. And for instance, for me, I've been working like almost 6-7 years on a specific topic. Just what right moment I see a right person or a company or people that are having this real world problem, and they pose it and they say, oh, look, this is what I really can do, but I was totally unaware of it. So it's just fun for me because I also get to know about it, and I can go and work on that, and also get to know more people that they may share the same common interest about that. So it was, I have to say, I really owe you that you really made this program such a fantastic one. Thank you all.
Since you are sending me your testimonials verbally or some in chat as well, Raj is going to send the feedback form out today. So please fill the feedback form, right? Because this is step 1 for us. Tell us how much you love us, but also how we can improve.
Yes, indeed. We will be sharing the feedback with all our partners so that they also know how your experience was, so that when they come back and also future partners come back, they know how better they can aid you, teach you, help your mind grow and expand. It is going to be good for you, but it is also good for them that they have got an extremely skilled and talented pool of people that they can potentially hire and recruit and deploy in the real world to solve real challenges and problems.
Like I said, we are friends who just met yesterday, and we have long friendship to go.
And by that, Prachi meant us, all of us, not just me and Prachi. We are not friends, but the rest of us.
No, I don't mean that you. No. All right. Who's next? Vineet, Johanna. Yeah, Kai, please.
From my personal side, and I would like to say thank you very much, especially to Prachi and Malo for your organization, and we are looking forward to have a future cooperation with you guys, and from our input to curious our winner, our opinion is we like your mathematical model, and I think you are maybe the only one team which provide your business model. I would say this is great. And my personal input to the UCLA team, I really like your this quantum chemistry product, but it would be great if you, I mean, for the future, it would be great if you can do some demos, because quantum chemistry is quite complex, and I think this would be a bonus for your career, or your PhD, something like this. And thank you very much.
Also, thank you, Kai. You,
thank you, Ray.
From Deloitte, Barbara, Nicholas, and you have been extremely not only helpful and supportive, but I think that you have added an extra dimension to the experience of our participants, which they will only get to know many years down the line, because you did come and add some new things, and we were able to see and recognize that, and we hope that in time many of our participants will also learn some of the interesting real world experiences and skills that you have come and shared. So your presence was extremely invaluable. Thank you.
Yeah, thank you too, Ray, and take care.
Yes, you too. And if you're ever in Washington, DC, let us know because our team is in DC.
Okay, we will let you know. Yeah, but good luck to all of you.
Perfect. Taha, I know you wanted to share something as well.
Yeah, so we won twice, so I thought that we can speak twice. So yeah, I'm from Constantine Quantum Technologies, and yeah, it's amazing that we won that prizes. I just want to thank all the Womanium team for this amazing program. We learned a lot, and it was very, very amazing. One of the best quantum program I've never attended. And I also want to thank all the members of Constantine Quantum Technologies, most of which are my students. And as I've already told them, you got great opportunity with this program and you maximize the output from this opportunity. So I'm very proud of you and wish you all the best. For next steps, we would like to have maximum opportunities with Womanium, and also to create our startup for quantum services. Why not? So looking forward for the future within quantum, and looking forward for working with you.
We are losing Taha.
Yes.
I think Taha broke up, but I told you, right, we have many students who are very young.
Thank you very much for all of you.
Oh, thank you, Taha. You broke up a little bit in between. So as I mentioned earlier, we have a lot of students, and a lot of Professor Taha students have also been participating, and you just heard from Nasser. And I also said that there are many professors also. So Taha is one of the professors who is still a student and who is also a professor while also being a student.
We should always all be students, right? That's the point of life, to always learn. So Amirali, you had your hand up for a while.
Amirali, 1 minute.
It's starting the countdown.
Just really grateful, just immensely honored, immensely just don't know what to say. Thank you so much for holding this. I remember it's been really long. It's been amazing. I just wish I see the counter going. It's okay, but I'm just grateful. Thank you so much for this opportunity, and it's been an honor. It was my first hack, actually. I didn't know I enjoy hacks so much, so it's awesome. It's great, and just looking forward to seeing more of the Womanium team, all of the other mentors. I'm actually working on researches, so I would always love to have mentors. So great, and thank you so much. I'll see the time running.
See, it works.
It works, and also, it is interesting that you mentioned about the hackathon part, because from our team sides, we did not have to do the hackathon, but we actually wanted to see what you are capable of learning in a short amount of time and also doing. And we will take this feedback to many of our partners, which that includes university partners, industry partners, but also we have been approached by many governments from across the US governments, different departments, all the way from White House to Department of Energy to others. They also want to know about how they can actually advance quantum science, and we will be providing some of this feedback to them as well.
Yes, so maybe I'll rephrase that. I think the question is, how do you now apply everything you've learned to real world problems? And this could be that you're in the Middle East and have a lot of oil and gas companies around you. So you think through their problems and say, okay, here I am, I can help you with your problems. Or again, whichever sector, right? You're in Sweden and you have a big healthcare industry, and you can ask them, well, how can we use quantum technologies for your thing? So we want you to start thinking of, again, the applications here. Vineet, you have your hand up.
And also with respect to hackathon, we had an interesting group of team working on the hackathon, and your experience of not only learning, but also having all these mentors come together is because of our small hackathon team.
Well, so Vardhan is still here. Vardhan, if you want to share hackathon experience.
And also, since you mentioned that hackathon is new for you, at the very beginning of our program, we were gifted with a person whose name actually means gift. So Vardhan actually means gift in, I think in Hindi, Urdu, etc. So Vardhan came to us and he said that he he has got a kind of addiction towards hackathons. So whenever he hears hack, he's just like zoom hack. So he heard about the Womanium program and he came to set up the Womanium hackathon. And your entire experience.
Oh, this is 1 month before the program starts. He's like, oh, I would love to, I heard about your program. Can I volunteer? And everything we had today was because of him. A lot of what we had today was because of him. Go ahead.
Our other hack team, Jyoti, Emily, Maho.
So I had like a great experience this time. Usually I'm the one participating and winning these hackathons, but this time I said, like, what actually goes on behind the scenes? So I wanted to explore that as well. And during the course of this event, I made some fantastic connections. The Womanium team has been like really, really great helping me because I was actually starting in this thing, right? I did not have any experience hosting events. I did not have connections. And being with the Womanium team actually taught me a lot of things, which I had no experience of before this event. Other than that, I had some amazing interactions with the participants, which of course had some really great solutions. So yeah, this was a really fun time.
Yes, Vardhan, we gave a lot of prizes and gifts to many participants today, but those prizes and gifts would not have been possible without the gift of your contribution from a man named Gift itself. So thank you. I think if Maho or Jyoti are here, it will be good if they can also come online and share some of their thoughts and experiences. But as they come online, Vineet.
Oh, thank you. I just want to say I'm very grateful to the Womanium team. 2 months ago, I had no idea what quantum computing is. And here I am after 2 months. I have 2 certificates, Q Bronze, Q Silver,
and
hackathon winner, my first hackathon, and a potential startup idea. So, you never know where life will take you. So yeah, thank you for the opportunity.
Yeah.
And I met some wonderful people. I enjoyed working with them. And we kind of complement each other's qualifications in a way. We have someone who is good with business, good with classical computing, quantum computing, and stuff like that. So, yeah, thank you. Oh, by the way, I would like to volunteer with your team for your next event. I hope you have some events in the pipeline. So, yeah.
Yes, indeed. Many programs in quantum sensors, in some satellite design and testing. So we have varied interest and we have varied focus, and quantum is just one of them. So
and also quantum consultancy. So yeah, one idea is again an extension, but you apply it to the real world and you earn real money. So solving real world problems, and it's a consultancy model. So it's project come in, it takes time to solve it and give it delivered back to.
Kind of like the hackathon, but for real problems with the real entities. Many times people might need help with certain aspects of it, and we will train you and then you will go and solve it for them. That is approach.
But that's perfect. I already have a couple of years of work experience in consulting industry. So yeah, perfect.
Excellent. So
just count me in for your next endeavor.
Definitely send an email to quantum@Womanium and also Womanium@Womanium, and we will get started.
Yeah, will do. Thank you.
Excellent. It is good to have you here. And also you're located in India, right?
Right now I'm doing my second year PhD in Norway.
Oh, okay. Norway.
Yeah.
Wait.
Oh, yeah.
Herman is in Norway.
Yeah. Fellow Viking. Hello.
Hello.
Herman, did you know that he's in Norway?
Yeah, I think you mentioned it previously.
Yeah, we had a chat. Yeah.
But I can regarding that, I can add that I worked at the first there's a research facility called Sintef, and they were sort of the first research group doing any quantum at all in all of Norway. And so relative to the if you took this group, the participants of the hackathons, and you put them all in Norway, they would be in the 1 percentile of quantum computation knowledge. So don't underestimate, what you've learned in this program and how far ahead you are of 99% of other people, because it's such a new field, and yeah, this program has taken it really far. So it's not like, oh, you know, I'm just one of many participants, everybody knows quantum computing. Just participating in this will make, yeah, you have skills that very, very many people don't have.
And also, Herman, coming from Herman, that is also interesting, because Herman, can you please share what you did at MIT? Because you also have a background in quantum.
Yeah. So I went to MIT. Actually, I didn't know what I was going. I know you want to do something with plasma physics, or sorry, with fluid dynamics. And then I realized that, you know, what's the most fun with fluid dynamics to do? Well, it's combining it with electrodynamics too. So it's plasma physics. And at MIT, they have this this group called, or a center called PSFC, so Plasma Science and Fusion Center. And they're connected with a group that researches fusion energy. That really recently did some breakthroughs. But so I joined the group of a professor there. And I happened, almost like this quantum program, I just happened to take one class in quantum computation. So I did all this other stuff, you know, classical mechanics and plasma physics, but I had like 1 foot in the quantum computation door. And then I mentioned this to my plasma professor, and it was like, oh, great, I have this grant. So Nuno Loyola is his name. I have this grant from the DOE to use quantum computers for plasma physics. And nobody had done that before, and we, you know, it was sort of a long shot. You know, let's try this, sort of like this hackathon challenge, right? Just find something. Let's see what quantum can do for it. And you know, we put together a team. We dove into the materials. We collaborated with a group from the University of Maryland, and then quite by random, a friend I was talking about, you know, how do you solve these plasma physics equations? And a friend of mine, he said, Herman, in this other random class, control theory class, I heard about something called Kalman linearization. It seems like something that could be relevant for you. And then I tried to, what is this Kalman linearization that is talked about? Very few people are writing about it on the internet, but I found some details in an old book from the 1930s. They really like dusty old book that I bought or got from the MIT library. And it turned out that in this book, I feel like it's felt like Harry Potter sort of, opening some forbidden book, and there's like a demon coming out. Some weird, or I don't know if he's weird, he was most likely normal, but some Polish mathematician had done some strange mathematics at some point that turned out to be very relevant for how to solve nonlinear differential equations on quantum computers, but he didn't know that. So we took this ancient knowledge, or 100 years old at least, and we applied it and created a quantum algorithm for solving nonlinear differential equations. And that's sort of the background for why I created this challenge. So yeah, it's sort of like I had taken like 1 month of quantum computing classes at MIT, and suddenly that was enough to get me into a research group with some of the best scientists in the world, because they just needed somebody to know quantum computing. So similarly, if you know whatever you're doing, if people just know that you have some quantum knowledge, you will be like a superstar. And then you will be the person to discover, oh, you know, we can take this QAOA, and they will be like, wow, and they will, you know, throw money at you. And then it's like, maybe it will turn out you solve a problem too, which is even better. And you will find something good. So yeah, I realized that just now, that, you know, just knowing the thing, you know, from quantum now is really a leap.
Thank you, Herman.
Thank you for sharing, Herman.
Yeah, sometimes one good exposure and experience is enough to change the trajectory of your life. It is kind of like an old Hollywood movie or a Bollywood movie. You see a pretty attractive person at the train station, and you get off the train, and that will change your life. And similarly, you see an attractive topic, subject, industry, field, and you decide to take off from the train of your life just to get off at that station and pursue a different life. But everything needs a catalyst, and many of the things that we did was to be a catalyst to aid you in that.
And many helped us with that. There are many shout outs to give to all participants. I would like to highlight two that are in my view right now who have been so important for this program. First, Yining Xi, you have been hosting mentoring sessions every day from at some point in Q Bronze. It was well attended and it has been so important for everyone to learn these important skills and help each other. So Yining, we appreciate it so much from the Womanium team. Thank you for taking this initiative and thank you for taking that all the way to the end of the program with the mentoring sessions. Saba, thank you very much from QWorld for not only being a participant here, but also tutoring several sessions. This has been very important for everyone to not only see and listen to the lectures, but also see how it is implemented in your tutoring sessions. Saba,
I thank you for this opportunity to be part of both learning and, helping to learn others or helping to teach others. So it was a huge opportunity for me. And I guess you heard the prayer, right? Here in Turkey, it's prayer time. So I just want to say thank you again and mute myself so that, okay. Thank you.
Thank you very much, Saba. And many here, so active participants helping each other all the time. This also holds for Discord. Nasser, Mustafa, David, many more. You've all been helping each other and helping us with the announcements and technical problems. So without participants, for yourself and for each other, it couldn't have been possible. Nitin, you had your hand for a long time, but now you are gone. Put it on again if you want. Yes, there you go.
Hi. So I just wanted to say thank you, and it has been an amazing journey. Raj mentioned something about India. I'm in India, and if any way I can help Womanium team, I'm all in. I have noted Quantum at Womanium and Womanium at Womanium email. I'll be sharing. And Harman, Vineet wanted to do the James Webb challenge with you. I hope he get some chance to work with you in Norway.
Yeah, of course. I'm happy to hear that. It's
sorry, I had to choose between two challenges, but I'll surely work on your challenge too. Yeah.
Don't feel bad. I can handle it. I think I can deal with that. But yeah, thanks for being interested in it. And like for real, you should continue working on like quantum simulation of classical physics. I think is going to be a thing. So in your work, you should pursue that field. There are not that many. I think there are very many like undiscovered opportunities in that field. There's a lot of focus on other stuff, particularly near stuff things. But yeah, when the quantum computers are good enough, then I think quantum simulation of classical physics will for sure be a big field. And that's also relevant for the quantum sensing, like the next round. You might have noticed that at the end of the James Webb challenge, it was about how to use quantum sensors to feed them into the algorithms. So I'm really excited to see how that's going to turn out.
And Juliana, you have more to share.
Thank you for the
now you are unmuted. Please start over.
Thank you. Thank you for the opportunity of a lifetime. I thank you, Womanium team, for everything. I have to go now. Thank you for the excellent mentors for the challenge. Thank you for everything. That's it. Thank you. Bye.
Thank you, Juliana, for being such an amazing participant.
Yes. We can't visit you in Italy soon.
And Juliana, we are just starting, so there'll be more. So come back.
Yeah, but anyway, I wait for you in Italy. Womanium team in Italy. Bye. Thank you.
Ciao, ciao.
Thank you so much.
And it was amazing to work with Juliana. Yeah, she was like always very enthusiastic, very helping. And our team Curious, we had participants from India, Italy, Norway, Alex, who is actually
Hungary
from Thailand
and Germany.
But she's
Hungary
in,
and Germany.
Alex is from Thailand, working in Germany, and from Hungary, Budapest. The other one, Gorge, yeah.
Yeah, I think the point here is, look, you found some people you like working with as well, right? So keep these friendships close. They will be your next startup founders, or next time you join a company, when you think of, oh, who are good people I would like to work with, you pull them in. So this is good.
Or perhaps, when you travel to these cities, you will need a place to crash. For example, when Herman comes to DC, he crashes on my floor.
That's so fun.
Yeah,
so funny.
Yeah. And perhaps you are really at high speed now, right? So I would say don't lose the speed, but keep going now before you take a break of a few months and life diverge, right? This is the moment to stay in touch and keep working with each other.
Yeah, and yeah, we should talk also of like what kind of support you need to make this into something real. Like Deloitte was really supportive of the challenge. They really respected all the work you were able to do. So I think from their side, would also be curious to see this to its next phase.
Mm-hmm.
I'm just curious to know, did Deloitte have a say in who gets to be chosen as a startup potential candidate, or is it just the Womanium team?
Both.
Okay. Wow. That's...
Yeah, every company and every judge had an equal say in picking the final startup winners. And they picked their own challenge winners in their category because they were well versed with the challenge category. So Herman picked the James Webb, Womanium picked the Womanium categories, Deloitte picked the Deloitte categories. But for the startup, we all came together and come to a unanimous consensus who has got the potential and who should win. But it's not about winning this prize. It is about what you end up doing from here onwards. So there are two kinds of people, and this is what I have many times observed. There are some people who go to a program or a university, they want to get the A grade and get the degree. And I need my degree so that I can hang it on my wall, and then I can send it to my relatives and tell everybody that, oh, I got a degree from MIT or whatever. And then there are people who are like, yeah, I want to learn something and I want to go and do something else with it. And a good example of that is William Phillips, the Nobel Prize laureate who came and spoke here. He also shared his journey of going through a college. And when he applied to Princeton, and somebody from Princeton said that we don't take people from your college into Princeton. Then he applied to Princeton, he applied to Caltech and MIT, and he got into all of them. And then he went to MIT, and MIT is like, you are the exact kind of people that we want here. And he did not just go there to get a certificate from MIT that he can hang on his wall. He went on to do great things. So for some people, they see something as an end. For other people, they see it as a beginning, and always see this as a beginning to something new, So something that you have not considered before. And also I would recommend that you watch this movie. I think the movie is from 94 or 97, and it is called Before Sunrise. It is about two people on a train from Vienna to, I think to Vienna. Yeah, so Vienna to Paris or something. And they randomly meet in the train and they make some decisions, and it adds a new dimension to their life.
Sure.
It's definitely a beginning for me. Thank you. Thanks for the advice, Raj.
And also watch that movie. It will. It's a good movie.
Before Sunrise, noted.
Yes, it's about two people meeting in a train, and they just start talking to each other. And the guy has to get off, and he asks the girl whether she wants to get off with him for a short duration. And sometimes, people make certain choices, and it adds new things to their life. And you also made a choice to participate in this program, the hackathon, create teams, attempt things. So start this something even new.
I'm curious.
Yeah, I wonder, Abdurrahman, are you there, the James Webb Challenge winner? Yeah, I'd love to hear from you. What's next for you?
Okay, so first I will I want to thank everyone from the Womanium team as well as you. You've been a good mentor for all of us, my team and all the team participating. So to be clear, for me, I've been just I entered this whole program out of curiosity. It was my first time doing some quantum computing, my first time participating in a challenge. I think that in future, in any they ask if we would like some kind of special kind of special new things to discuss, to do trainings in the future. I think that anything is welcome. I'm very I'm very open to learn, to have an idea about fields that are related, since I work at the university, and usually we have to discuss with people from other fields. It's very good to have an idea about what they are doing. So thanks for you all.
Yeah, thank you. And this is totally what Womanium is about, taking people, training them, and now you will be Womanium's representative, spreading the quantum knowledge where it's needed. So.
True. I think
it was a very interesting journey.
I think even in some sense, Herman is also a good example of some of the Womanium style of thinking.
Parminder, good to see you.
Good to see you, Prachi, too. If you probably know or don't know, I and Prachi both work for AWS. And it was nice to participate in the month-long event. We had a break, means Dinesh and I are attending the master in a master program in quantum computing out of University Polytechnic Madrid. And we start our second year in fall. So this was a nice little break and do some of those hackathon and then the program. And earlier when you guys were judging, so somebody asked me like, okay, how I transition myself and then what I will be doing. So it's news, but I will be starting a quantum architect role, helping the ISPs to use AWS as a platform, and mostly on infrastructure side, how they can use that to create some of these new solutions. Companies like Classic, and potentially the companies like here whom we are talking. If you ever need any help, my job is probably to work with these companies and provide an infrastructure, whether those are POCs, credits for the AWS. Happy to help in that sense, but it was a nice experience to learn and work on some hands-on knowledge, but I'm all here, and I would also probably work with Prachi and with other Womanium team members, how as AWS can help more, and how personally also I can contribute more into this program in North America or globally. But thanks to all of the participants as well as all of the organizers.
Thank you, Parminder. Yeah. And what you're trying to do is something really interesting from the realm of internet, and it will be great to learn about what you're trying to accomplish from our side, from within the team, but also perhaps for some future programs to share what AWS as one of the largest cloud providers, how you are trying to innovate. Because in order to do innovation, you need good people, good talent who have got the right skills and the right outlook. And it is always good to share that a little bit early on so that young people will start thinking along those lines and come up with very dynamic and radical ideas. Or maybe just they have the energy and enthusiasm to do some fun stuff, and that will end up changing things. So please do stay in touch. Please do come back and share what you're doing. And also please do send an email to Dr. Marluslot, explain with a little bit more details of what you're doing. And we should engage more.
Thank you.
We will have some fun. We should engage more.
I'm curious to hear from you, David. You have had such great input and questions throughout the whole program.
David Liu?
Yes, if you are there. If not, if there are other people, what are your next steps in general in your career, and has the program the past 7 months changed anything in your thinking? Sarah, are you there? We talked in the very beginning about your quantum journey.
Yeah, I'm here, and I was about to say thank you to all of you, and I'm going to miss the whole team and the whole session and the daily meetups and the daily the things we have gone so used to this, but it was like an amazing program, and before that we were not that much into quantum computing side, so it was like getting known to the latest things and the latest companies, what they are up to and what they are doing in the future. So it was like so wholesome thing for us, and it's like now we can stand and we can tell people about quantum computing in our ways, what we have learned through your program. So I would like to thank you all for that, and it was an amazing session. Hope to see you sometime at some other place or at the same place with some new stuff.
Yeah, same place, Discord. We will stay active. So keep checking your Discord as well. And look, this is the first step. We're going to help you and help each other with career opportunities, new papers that you publish. Whenever you're in the news with your billion-dollar quantum startup, we're going to be here to cheer you on. So we are here for life.
Thank you.
Yeah, wonderful to hear, Sarah. And Mustafa, when will you start your startup in quantum brains and brain and quantum interfaces?
Hello, can you hear me?
Yes.
I highly appreciated Womanium team, especially Marlo, Prachi, and Raj for organizing this valuable workshop. As
No, Mustafa. There is a lot more people who actually did things. They were not every day on the screen because they were in different time zones.
Yes, all of the team members.
Vardhan, Jyoti, Jade,
Jyoti,
Millie,
Elizabeth,
Elizabeth,
Lisa,
Lindsay.
Alex, Madalena.
Exactly. So,
and all of us also have other things in the meantime. For example, when Raj did a shout out to the rest of the hackathon team, most of them had just left because their lectures were starting again. University started again here in the US. Yeah. And same actually holds for Raj, Prachi, and me. We have our normal work in the meantime.
Exactly. We wrap up the sessions here, and then we spend 8 hours doing our real world jobs. And then we try to.
And then we return to you.
Exactly.
Yes.
Thank you all of the Womanium team for organizing this program. Actually, I participated in different programs like hackathons and QC hackathons and some workshops, summer schools, but it was the Womanium program was a kind of complete packages in software, hardware, entrepreneurship. It was great opportunity for me, and it is my dream. Q Iran should be a hub in Iran, in this region, and try to train more people in quantum computing to be the next generation scientists in this world. It was a great opportunity for me to gain some experience and transfer to my team and to other people in Iran. Yeah, thank you.
And please, if there are virtual events from Q Iran, please invite everyone. We look forward to joining.
Yes, actually, we organized some 2 workshops at the level of Q Bronze, and after that, we want to organize Q Silver, and we have many programs in Iran. We want to invite all specialists in this area and have a kind of talk and webinars and mini projects, and we decide many programs. We decide to organize different programs in quantum computing, in Iran.
Perfect. We are your partner for that. So we'll have certainly.
Thank you.
Yeah. Saba, any more thoughts from you?
Yeah, I guess I can talk right now again. So I would like to, share my appreciation for your team, for Womanium, for this, energetic team to provide us such a good opportunity to learn and go beyond our limits in quantum world. And this was a huge thing for me because I was both a part of the team and the students. Yeah. And I get to experience from both sides, and it was really special. So I really thank you for that. And as QTurkey, we also have our quantum, programs. We continue to do them. As a matter of fact, we have a hackathon upcoming in Turkey, and I would like to, make announcements about this. If you're interested, please just check our LinkedIn profile. Thank you.
Perfect. And share it on Discord, please.
Yeah, sure. Of course, I will. Thanks.
Yeah, it really makes me think. It really started with one little message among the three of us, Prachiraj and me. I think now if we wouldn't have sent that message, then everything could have been different the past months for many people. And it was such a great time getting to know all of you and going through this program all together, getting to know you, Saba, Mustafa, Taha, Sarah, all of you here. We have planted this seed, and as Prachi said in the beginning, she showed the dancing plant. This holds for quantum trajectories, and this holds for the friendships and context that we have built within this program.
But we are just starting, so there'll be more.
Yeah, it's not farewell, so.
Abdella, are you still there? You had this amazing pitch about topological quantum computing a while ago, and then you leveraged it with the team to a great education module. Yes, you are unmuted. Does it work? We can't hear you. Okay, please try later again. We'd love to hear from you.
Hello.
Yeah, there you go.
Yeah, thank you. I would like to give thanks to all Womanium team. You did really a great event. I didn't attend such high quality and large scale event with this intense and large community from all countries, almost all continents. So it is. I cannot find a way to thank you. I would like to, I hope that we have did what we should do in this event, and we have and I hope that we have helped each other and learned. Personally, I learned a lot of things from you and from QWorld and all the sponsors. Thank you, everybody.
That is great. And we still have your 20-minute video too, which we will share with the participants because it was a great instructive video about topological quantum computing. Taha?
Marlo,
the internet is very weak.
Small word, if I can, Marlo, just to say that Abdullah, despite of being a great physicist, he's a very timid person. So congratulations for you, Marlo, for being able to making him saying something here.
Yes, and thank you so much, Abdullah, for doing it and pointing this out, Taha.
Is there anything that anybody else wants to share? Because it has been a long session today. We went through a lot of roller coasters, setting up the program, bringing in all our judges, judging, selecting the winners, announcing the winners, selecting the startup, announcing the startup, and giving additional information. and also sharing with you some of the experiences and journeys and listening about your experiences and journeys. And also hoping that you will take it and go much higher, much further, and much ahead. And if there is anything that you would love to share before we conclude, that would be great. But as I said, this is just the end of chapter 1. We are writing a bigger chapter in new areas with new programs.
And really, please share your thoughts, what you want to see and what you want to do. Yining, I see that you unmute.
Yeah, I also want to thank Womanium. It's so wonderful. After meeting, I'll send an email to Malo, Prachi, and Roger to share my thought after this meeting.
Perfect. Yeah, we'll send you all the feedback forms, but Yining, more than you being grateful to us, we are really more grateful to you. So thank you for putting all the team and the participants together and making this culture.
Yeah, particularly there was a question after that a talk with Nobel, Laurenti, Dr. Phillips, and there was some question left from that meeting. So that's one of the 3 things I'm going to email you 3 what I would like, my thought for next
That's
1 or 2.
great.
Thank you.
And also,
thank you again.
Also, Yining,
thank you, Womanium, and everyone, and all the students.
And to Yining and to everybody else, we will be sending a feedback form that is going to be your last assignment in this program, so that you can share your experiences, your thoughts, your ideas also. And just about a 2-page report. We will send you the pointers and you can respond to that. And we will also send some sample assignment feedbacks from the past so that you know how to write and structure it.
Yeah. Particularly, I want to thank as oldest students of a elementary school, oldest student of elementary school. That's me in this among the students. So I want to thank you very much.
Oh, wow. And again, we can thank you
and
again.
I'm truly elementary school compared to everyone else. Appreciate it.
And again, we can't thank you enough, Yining, for hosting these mentoring sessions every day. Thank you so much. With that, let's conclude this session. Thank you all for staying so long. It has been amazing session since the start. Amazing to see all your pitches. We will watch them back from the breakout rooms. Great to touch base with you afterwards, hearing about all your plans, and we really look forward to staying in touch and doing many more great activities together.
Excellent. So thank you, everyone. And in about a minute, we will end the session. And thank you, Vardhan. You got to see the results and the fruits of your effort. So thank you, Vardhan.
And you should all thank Vardhan too, because he has won every challenge he's participated in. So you all should thank him for not participating in your challenge.
Yeah, he could have gone home with all the prizes.
Exactly.
Yeah, I've done a lot, and I've tried to, regarding the hackathon, I try to go as fast, as far as I can. But as I mentioned earlier, I'm from elementary school compared to all others, but I did, try to as much as I can. So, more important is, like Raj said, beginning of Pontoon journey. That's what I'm going to send. And also there are additional 2 points I'm going to send you 3.
Great.
In my thought. Thank you.
Bye.
With that, wish
Thank
you all
you
a
very
great
much.
day and see you tomorrow.
Yeah.
Looking forward to that.
Yes, and tomorrow is a career fair session. Many companies, many representatives, many opportunities, many new journeys.
There we go. Thank you all. Have a great afternoon and night.
Ciao, ciao.
Bye.
Bye.
Bye. Bye.
Good night.
Thank you. Bye.
Thank you.
Goodbye.
Bye bye. Thank you.
Thank you and bye-bye.
Thank you, Fatu. Great having you.
Herman, you're still here. So is Mustafa. Very, very difficult to leave.
Yes, very difficult.
But we are not leaving.
I'm gonna lose you again, Raj. If I close it, I'll never. Yeah, I'm afraid we'll go.
Raj BSA with Womanium all the time.
Yeah.
No, we will be coming back with new and exciting programs and new and exciting opportunities. So we are not leaving. We are just
okay.
See you soon.
See you soon. Bye-bye.
Bye.